Mainly, there are two types of steel, which is called carbon steel and alloy steel. So carbon steels are um, contain of carbon and also iron. So this type of carbon steels is not that much hard and strong. So it's called carbon steel. But in order to make it harder and be useful, more useful for a wide variety of application, um, uh, is alloy steel, and they need to mix with the other types of metals. If we add another metal in carbon steel, so we can make alloy steel, which is harder and more useful. On these two tables you can see a list of carbon steels and alloy steels, um, and their usages, their properties, and the types of metal and other components that are used for making alloy steels. Alloy steel, and one issue related to the carbon steels are tend to be rusted. They are easy to react with the oxygen in air or oxygen in water. So what is the rusting of iron or steel? So as I said, when any metal attacked by air or attacked by oxygen actually, which is in air or water or other surrounding substance, is called corrode. That means this is a general word for all metals, but in the case of iron and steel, only for these two, this correction or corroding process is called rusting. So rust is a red brown powder consisting mainly hydrate iron. So the chemical formula is Fe2 oxygen 3 and some molecules of water also. So I'm sure you have been faced with this situation when you leave iron or any iron stick in somewhere because of air or moisture, maybe if the place is wet. So after a while the iron gets rusting. So the rust is the red brown powder around the metal. I'm sure you have faced with this type of um, iron. So yeah, if the environment, the surrounding has salt, so this situation will be worse, like um, like seawater, any um, like a boat or ships that they are placed in seawater. So seawater is contained of salt, so which makes the situation worse. And on the other side there is aluminum is more reactive than iron, but they cannot be corroded as much as iron, because the first layer of the atoms on aluminum, when they react with the oxygen in air, so they make the very um, thin layer of the aluminum oxide. They form an aluminum oxide, which that aluminum oxide can protect the the next layer of the aluminum. So the next layer of the aluminum can be protected by the outer aluminum oxide layer, and and also yeah, that is for iron. And chromium also is similar with the aluminum. The performance is similar with the aluminum. They can be protected by the first outer layer of metals atoms, which they are oxide, which they are being oxidized by the oxygen of air. And there is experiment to observe the rusting of the metals. For example, if you have iron nails, if you have iron nails and put in the glass tube like this, and there is enough air inside, and if you just cover the lid and then close the lid, so if there is distilled water and if there is air, that means there is enough oxygen available in environment, so the iron nail can get rusted. And the another one, like here at the tube 4, if there is only pure oxygen, not air, because as we know, air contains of nitrogen and carbon dioxide and many things. But if we inject only pure oxygen and distilled water, still the iron nail can get rusting because of oxygen. The issue is availability of oxygen. But on the other side, if we have a dry air, that there is no oxygen, or it's not wet air actually, and um, so yeah, that iron nail will not get rust. And if we put this iron nail in the water which is boiled distilled water, that means there is no air inside. The air has been removed, but we cover it with a layer of the oil. If we put oil, that means the air cannot move to the water. So there is a water, but there is no oxygen in water, and there is an air in the tube but cannot move to the water. So still you can see the iron nails still is not attacked by the oxygen and it's not rusted. So there is so these are four tubes that shows the condition is required for rusting the metals. But there are many methods that can be used for preventing the the metals against to be rusting. One is painting. Um, Painting is a common method, and also it's cheap, but it's not constant, and after a while it need to be used again, and as long as the paint layer is unscratched. The another one is oiling and greasing. Instead of color, we can use oil or grease uh, to coat or to cover the metals. And the another way is a plastic coating. Instead of color or oil, we can use plastic. The plastic is form of liquid, is a molten plastic, like a refrigerator or a garden chair. So garden chair has iron, and also refrigerators or fridge, they have iron, but they are not rusted for a long time using in a home because of plastic coating. They are coated by plastic. So plastic also cannot be attacked by oxygen. And there is another method which is called electroplating. This method can be observed in can. For example, when you buy a can of bean or a can of um, tuna, for example, or fish. So they usually they are kept in the can. Okay, the can is a steel or other types of metal, but they are protected by chromium or tin. Tin is another type of metal, like a chrome. So they are coated by these two and protected. So um, one advantage of chromium or tin is they are not reactive and they are not toxic. Another method is galvanizing. Galvanizing can be used for uh, so yeah, here they said an object may be coated with a layer of more reactive metal like zinc. So I explain here, like aluminum's performance, like aluminum and chrome. I said the first, which is outer layer of the metal, can react with the oxygen because it's very reactive. But that oxide of the metal can protect the next layer of the metal. So this is the same, can be adopted for galvanism. Galvanism method is the one used by zinc. Zinc is more reactive. So they coat or cover the metal with zinc. Once zinc react with the oxygen, so the zinc oxide will be produced on the surface, the outer layer. So that zinc oxide can protect the next layer without any reacting with the oxygen. The next one is sacrificial protection. So reactive metal are attached to the iron surface, zinc or magnesium. Yeah, these are also another look like galvanism, but they use zinc or magnesium in some part of the metal. And another one is electrolytic protection, which is can be used for a very large and static steel structure. So as you can see, here there are some methods that you need to memorize. So far in this chapter, there is no formula, or there is no something that you need to use the patterns or formula. It's just memorization. This chapter is mostly connected to the memorization style that you need to read and learn and then boost your knowledge. Here there are two pictures related to the rust prevention. This one, you can see that the iron in a very big structure like sheep hulls, that they are placed in the seawater. As I said, seawater which contains of salt make the situation worse. So for rusting the metal. So they use the zinc at some part of the iron, so that zinc can protect iron by reacting with the oxygen or oxygen in air or water. And the another one is electrolytic protection of oiling structure. Again, this structure is located in the seawater or oceans water. So they use a power resource to coat to constantly coat the metal, the the oil rings structure, because the structures are made by metals. So they need to use a power and also titanium anodes and another part which is cathodes. We learned these in previous chapters in electrochemical process. In the previous chapter we learned about this process, but here it's a very bigger scale. And extraction of zinc, so we learned about the extraction of iron and how to make after extraction iron to make the steel, which is actually pig steel. And here is extraction of zinc. Extraction zinc, the source can be used for extracting zinc is zinc blend, which is sulfide of zinc, the ZNS. Also, we need a current of air. That means we need to make a reaction between zinc blends, like a zinc sulfide plus oxygen. Then also a high temperature is required for running this chemical reaction. And finally, uh, sulfides can react with the oxygen and make sulfur dioxide, which is a gas and can leave the place. And the rest will be metal oxide, which is zinc here, zinc oxide. And the next step, we need use carbon to reduce. Actually it's a reduction process, like iron. Like iron we use carbon monoxide. Here we can use carbon monoxide, also we can use carbon or just a solid structure of carbon. Then zinc oxide need to be reduced more because still there is oxygen mixed with the zinc. So we use carbon. Then carbon is very reactive with oxygen to produce carbon monoxide, which is a form of gas. And then zinc will be alone, will be purified. And another one is extraction of copper. Just keep in your mind that extraction copper also same as zinc, but only the resource which is going to be used is the copper pyrites. Copper pyrites are CuFeS2, is a source that can be used to extract copper. On the right side you can see a general procedure for extracting zinc or copper or iron. For any extraction, this procedure can be used. Please focus on these figures. Don't leave it, and be easy going with the figures, because they are good choice. They are good choice to be as a part of your exam. So you need to detect every part of this procedure, like the zinc vapor here, and then how it can be separated, zinc oxide, and also the hot air that they inject to the chemical reaction. And please have a look at all the pictures. So that's all for today, and we will continue next part in the next session. Thank you so much. Stay safe at home.